Okay, let's start. This is our main scripts, which is written in the Jupyter notebooks. And the first thing we should do is to import the libraries. And then we should define the field paths and the LS settings, which is the most important. And we should define both the rank, which is the dimension of the user, and the business features, and the number of iterations. Okay, to save the time, we only use the rank of 10, and the iteration is 20. Okay, let's load the data from the fields. Okay, we could check how the data looks like, and we should use this command. Ratings take 5. Okay, it might take some time because we are loading the data. Oh, it's here. Now we should split the entire dataset into the train dataset and the test dataset. Okay, we should use this command and run these scripts. I have already run it, so we see we only take less than 1% at the test data because it takes so much of times. Okay, now we could use the training data to train the models. Okay, and this is the function we used. Okay, now build the collaboration filtering model based on the training data. Okay, we should run this. It takes about 1 minute if we use the rank 10. Okay, let's wait. Okay, now we have these training models. Okay, it takes more than 1 minute. And we could also calculate the mean squared error for these training models. And I have already calculated. It's about 0.2. And it takes about 2 minutes. Just ignore this in these recordings. And we could also save these models and add some kind of provide some names. And we could see if we run these scripts and you see, and this is our training models, and it has the business features and the user feature metrics. Okay, it's here. Okay, then we could directly use this kind of models and do some kind of predictions. Okay, it's not. Okay, after we have saved these models, and we could load these two metrics from the fields, and I have loaded it takes some time, and then we should test our model based on some new users not existing in the training data set, and we could select some from the testing, from test ratings from the test data set, and for example, the user 400, and this is its ratings and the UID, business ID, and the ratings. And based on this kind of input, we could calculate using the linear regressions and to predict the features, predict the user features. And based on our we doesn't use any iteration method. We just use the normal math to directly calculate this feature. You could see, and we could see the mean squared error is okay. It's a little bit higher than our training. Okay, you could see the error is larger than the training error. It's reasonable. Now we could use our k nearest neighbors algorithm to find the eating maze like this. Okay, and this is the eating maze ID, and this is the normal distance, Euler distance from the original input. Okay, now we should get our eating maze and the recommended restaurants. And here's our scripts, and I have already. It takes a long time, so I didn't write it again. And we could check the scripts. And the first thing is to load the user metrics and then get the predicted features through the linear regressions. And this is the user vectors. And then get all the recommended restaurants for these particular users and save in the site. And then get all its estimates from the k-nearest neighbor algorithms. And then for each this estimates, we should get the recommended restaurant for it, and calculate the shared top rating restaurant with the base users, and that's our result. Okay, now let's check what we could see. And this is the estimates the UID, and it's the similarity between the base users, and these are all the recommended restaurant for them. Okay, and you see the mean square error is the same as before. Now we are done. Okay, after we got our training models, and we should try to build some real web applications based on our recommendation systems. And this is the main scripts, and we have load some necessary libraries and loading the necessary data, and most importantly the user metrics and the business metrics. And then this is our some helper functions, and this is the most important is the getting taste. And if we get taste and we provide some user IDs, and we would generate the recommendation restaurants and the eating maze and the taste analysis. And okay, let's run it. And this is the result of 9. Let's change it to some others. Example, recommended users and taste equals to some get taste. For example, let's find the 400. It may take some time, and if we could got the result, we should also print it out and recommend users and the taste. Okay, we got the result, and this is the recommended restaurants, and this is the eating maze, and this is the taste analysis, which is the list, and this is the categories, and this is the term phrases, and we could chat it later in our front-end UI. At our front UIs, and first we should go to this directories and where our server lives, and then start it with Python. Okay, now let's look this in the website, and here it's localhost. Okay, now you could see this is our the main page. We will start. Okay, now we want to look for some eating maze. We should provide some ID, for example, the 9. Let's click found. Okay, this is the result. We got the taste analysis, and it's in the word cloud. We implement in the word cloud 2 with the jQuery, and this is the eating maze. And we see we recommend 5 users and both 5 restaurants, and test them to eating together. Okay, and to change other users, we could provide some other ID. For example, like 16. Okay, you will see. Oh, they both like pizza. Let's try some others. For example, like 1. Oh, everyone likes pizza. It's normal. It's in American. And 23. Okay, now the sandwich and the muffin become pop out. Okay, we are done here. Another thing I want to mention is how we collect the data. We're using scraping or Python crawlers, and I will show give a brief demos. Okay, and it includes the 2 parts, and the first is Yelp features, and the purpose of this is to grab some data, the business list from the Yelp's official APIs, and here's the resulting data. You can see it for the different cities, and this is the the structure, and the first is business ID, business name, its general ratings, and its categories, and its location, and the total number of the reviews. And there were so many cities. And then the second thing is to grab the reviews. And okay, you could see this is the logs, and okay, this is the spiders we implant. And the first thing, we should define the input data, which is this is the path to this kind of data. And normally I just copy paste it to this data. Okay, now it's not here. Okay, now we load the business list, and we get its IDs and put in the queue, and then we start the spiders, and then we pass these reviews, and we get UIDs and the users and the ratings, reviews, and most important, the next page. Which each page only contains 20 reviews, and we got the links to the next page and continue it, and then pass it and pass them to the pipelines and pass them to pipeline and send them into the fields. And here is the result. Oh, I cannot open it here. Let's check it in the vendors. This is the Scrappy, and okay, you could see. Oh, the data is empty. Okay, since it's empty, we could start it. Okay, for example, let's grab some data from the bottom. Okay, it's here. Copy paste this name. We got his name, and we revise this path. Okay, it's business button. Okay, let's start with spiders. Your subscribe IP. Okay, sh. Oh, it's in Python. It's written in Python 3. Okay, star.sh. Okay, now we could see we start this. We could see a lot of success, and we grab this kind of data. Okay, I need to stop it because I don't want the job to bound my ID again. Let's stop it. Okay, let's check whether we have this kind of data. Okay, you could see this is the data. And this is the data we just scrapped from the Yelp's webpage. And this is the user ID, the real ID, its name, its rating on this particular business, this business ID, and this is the content of the reviews. Okay, now this is our data set. And